Before we spend a lot of time with partial fraction decomposition for integration, I wanted to make sure you had a primer on how to do partial fraction decomposition. So if you're comfortable with it and you feel ready to go on, you can skip this video. If you need to come back to look at partial fraction decomposition, you can look at it here. But there's going to be no calculus here. This is all stuff that theoretically you would have covered in pre-calculus. But if you didn't, that's okay. Here's where we'll talk about it again. So looking at partial fraction decomposition, if the denominator of a function can be factored, then that function can be rewritten as a sum of simpler fractions. In other words, we can write something like a over x plus b c, b over x plus c plus etc. And this will make sense once I kind of show you the work here, but the idea is we're looking for a simpler sum of fractions than we had before. So here's an example. Rewrite 3x plus 2 divided by x cubed minus x squared minus 2x using partial fraction decomposition. So the way that partial fraction decomposition works is first we have to factor our denominator, which is going to give us, let me write it up here so we have it, x times x squared minus x minus 2. So that'll be x times x minus 2 times x plus 1. So we're assuming that there will be, we know that there should be a partial fraction decomposition because the rule with partial fraction decomposition is we write our original expression, and then we know that it will be able to decompose into something that looks like this. And this is just because of the properties of algebra in partial fraction decomposition. So this is somewhat of a formula that you just have to memorize, but it's nice and easy. You just put each of the factors, so x, x minus 2, x plus 1, in the denominator, add them together, and then just put a capital A, B, and C to represent what the numerator is going to be. What the rule of this is that there should be some number A such that this is true, some number B such that this is true, some number C such that this whole expression is true. This only works with linear non-repeating fractions or non-repeating factors, but we'll take a look at what happens on Friday, what happens when those are nonlinear or non-repeating. Okay, so we're assuming, because of the properties of algebra, that these two things have to be equal. So let's start figuring out ways to make them look more equal. So the first thing we want to do is write the right side as a single fraction. So that means we need to multiply, find a common denominator. So a times x minus 2 times x plus 1 plus b times x plus 1 plus c times x minus 2. And then all of that gets divided by the common factor of x times x minus 2 times x plus 1. So now we know that the right side and the left side have to be equal. We got that this denominator, x cubed minus x squared minus 2x, we factor that to get this. We can cancel that on both sides. And we'll be left with 3x plus 2 equals a times x minus 2 times x plus 1 plus b times x plus 1 plus c times x minus 2. So now what we could do is distribute the a, distribute the b, distribute the c, factor or express it all out, set up a system of 3 equations with 3 unknowns. But because these are factors, we can do a clever trick to solve our thing, which is say that x equals 2 to start. I'm picking that because I know that it will make this term and this term equal to 0. which means I'll just be left with an unknown of b. So with x equals 2, we get 6 plus 2 equals a times 0 plus b times 2 times 3 plus c times 0. In other words, b is equal to 8 divided by 6, which is equal to 4 divided by 3. Now let's get rid of this x plus 1 term. So I'm going to say x is equal to negative 1, and that will give me negative 3 plus 2 is equal to a times 0 plus b times 0, because we've got x plus 1 right here and x plus 1 right here, plus c times negative 1 times negative 1 minus 2. That's going to be negative 3. So that'll be c is equal to negative 1 divided by, on the right-hand side, we'll have 3. So c is negative 1/3, b is 4/3. And then we have to do one last number, pick x equaling to 0 to cancel out these two. And that will give us 2 is equal to a times negative 2 times 1 plus b times 0 plus c times 0. So in other words, a is equal to negative 1. So now we've solved for a, b, and c, and now it's just a matter of going back up, plugging those in. So negative 1 over x plus 4/3 over x minus 2 plus negative 1/3 over x plus 1. And so this expression is equal to the expression on the left. And if you want to check, you can go through and find the common denominator, multiply, and you'll see that you end up with the same results. And that's because that's what we did here. We multiplied through the common denominator. We didn't know what a, b, and c were, so we left those as unknowns, and then we just solved for them at the end. So this is the example of partial fraction decomposition. You can also check some of the practice problems, or if you have questions, feel free to ask me.